Hello guys. So today let's solve this lead code question, which is top k frequent elements. Right. So let's read this question. So given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Right. So what they're asking us to do is, so they'll be giving us an array, and we have to find the top most frequent elements that are occurring in this array. Right. So for example, let's take this example one where we have this nums 1, 1, 1, 2, 2, 3, and then we have k as 2. What they're asking us to do is we have to find the top two frequent elements that are occurring in this array, right? So here 1 occurs 1, 2, and 3. So the number 1 occurs 3 times, the number 2 occurs 2 times, and the number 3 occurs 1 time. So obviously the top elements that are occurring most frequently are 1 and 2. So that's going to be our result. And example 2 has only one number in the array and k is also 1, so we just return that number as the output. This is straightforward. And if you look at example 3, we have to find the top two most frequent elements in this array. Here we have the number 1, which is occurring once, twice, thrice, and 4 times, and the number 2 is occurring once, twice, thrice, and 4 times, and number 3 is occurring only once and twice, right? So 1 is occurring 4 times, and 2 is occurring 4 times, and 3 is occurring only 2 times. So obviously the top two frequent elements are 1 and 2. So the question is pretty straightforward and clear. Now let's go to the implementation. But then before jumping straight away into the implementation, let's think of the intuition here, right? So how can we solve this? So first thing that comes to our mind is if we should note the frequency of every elements in this array, right? So here 1 occurs thrice, 2 occurs twice, and 3 occurs once. So we have to maintain this frequency somewhere. So obviously map is a very good choice here. We will have key as the element and frequency as the value, right? So that's what we're going to do here. So we're going to have a map. Let's take this example. Let's go step by step. Okay, let's go step by step. So we have key and then we have value. So we have 1 which occurs 3 times, and then we have 2 which occurs 2 times, and then we have 3 which occurs 1 time, right? So this is our frequency map. Let's call this as our frequency map, right? So now once the map is ready, we have to get the top two elements, top two most frequent elements here, right? So the answer is 1 and 2, but how are we going to get that? So the easiest way or the straightforward way to do is to sort this map based on the descending order of the value, right? So if we sort this map based on the descending order of value, we'll get the top two elements, top k elements. So you can get top 3, top 4, top 5, or whatever. It's pretty straightforward to get that. So in Java, we have this method called collections.sort, and then we pass in a map. But then will this work? This will not work because map is not part of the collections framework. Only set, list, and queue are part of collections. Map doesn't come under collections. So this wouldn't work. So how are we going to solve this? We're going to convert this map into a list first, and then we're going to sort this list. Collections.sort and list, right? So this method sort, it always sorts based on the ascending order. That's the default behavior of sort. But then here we want a custom behavior, right? We want to sort based on the descending order of the value. So for that, we're going to pass in a comparator here, right? And this comparator is going to have entry set as your arguments. So what is an entry set? So in map, you store the key value pair as part of entry set. So using the entry set, you can get the key and you can get the value as well. So what I'm going to do is I'm going to do es1 dot get value, which will be an integer, compare to es2 dot get value. Since we want this to be sorted in a descending order, I'll just put a negative sign here and done, right? So now the map is sorted based on the descending order of value, and then you can just get your top k elements pretty easily, right? But do we have an optimized approach, or do we have an elegant approach for this? So before talking about the elegant approach, Let's see what's the time and space complexity here. So the time complexity is going to be O of n because we are just traversing this array only once, right? And then we're going to do some sorting here that would have O n log of n complexity, right? Plus O n log n complexity. I'm going to do some sorting here, and then the space complexity is again of n, right? Because we are having a frequency map and we are having a list, so we are having two different data structures. So it's O of n plus O of n, which is again O of n, and the time complexity is O of n plus O of n log n, as we are doing some sorting technique here. So now let's move to the optimized approach. So now that we understood this approach, this will definitely work. You guys can try it out if you are interested in solving this way. But then let's discuss an elegant approach to solve this. So in Java, there is a data structure called as priority queue. We're going to use that priority queue to solve this problem, right? So let's do that. Let me remove this. So we're going to solve using priority queue. So before jumping into the implementation of priority queue, let's understand what this priority queue is. If you guys already know priority queue, well and good. If not, just consider this as a minor refresher. I'm going to explain this on a very high level. So priority queue works on a default data structure which is called as min heap, and the elements that are added to priority queue are always uh, inserted from left to right direction, right? And by default, parent value should always be less than or equal to your child value. So these are all the properties of a priority queue. So let's try to understand this with a simple illustration. So what I'm going to do is I'm going to draw a binary tree kind of structure here, right? So I'm going to draw a binary tree kind of structure here. So before going to the binary tree structure, let's uh, let's have that frequency map here, right? So we had our frequency map, which had your key and value. So we had 2, which was occurring, I think 2 was occurring 2 times, 1 was occurring 3 times, and 2 was occurring 2 times, right? Right, okay. So we had 1, which was occurring 3 times, and we had 2, which was occurring 2 times, and we had 3, which was occurring just once, right? So even in this approach, you're going to build this frequency map first, and then we're going to use the priority queue to get the top k elements. Now let's understand how we can get that. So just for illustration purpose, I'm going to draw a binary tree, complete binary tree kind of structure here. So what I'm going to do is I'm going to take the value, right? I'm going to take the value of this frequency map and put them one by one here, right? So let's do that. So we have this value 3. So I'm going to put that value 3 here, right? And then I'm going to move to the next value, which is 2. So I'm going to put 2 here. Okay. I'm going to put 2 here, and I'm going to join these two nodes. Yes, one important point to note here. I'm just saying this as binary tree just for illustration purpose, but priority queue internally uses array as the data structure. It does not use binary tree. So I'm drawing this binary tree just for understanding purpose. All right. So let's continue. So we inserted the value 3 first, and then we inserted the value 2 now. Now let's look at the properties of priority queue. So we always said the element should be inserted from left to right. So when I first inserted number 3, it's the first value. We don't have any value. So this is the beginning. So we're just going to insert 3 straight away. But then when you're going to insert the next element, you should make sure if the parent value is less than or equal to your child value or not. So does this satisfies that condition? So the parent is 3 and the child is 2. So the parent is not less than or equal to 2. So this violates the condition. So what we have to do is we have to swap these two elements. So I'm going to put 3 in place of 2, and I'm going to put 2 in place of 3, right? So now I have swapped it. All right. And then let's move to the next element, which is 1. So I'm going to put 1 here, gonna put 1 here. Okay. Now, does this satisfies the condition? So we inserted an element at left. So now we went to the right side and we inserted one, which is good. Property 2 is good. But now let's look at property 3. In property 3, parent should always be less than or equal to child. The parent of 1 is 2, but 2 is not less than or equal to child. Again, this violates the condition. So now what we are going to do, we're going to swap these two elements. So I'm going to put 1 in place of 2 and I'm going to put 2 in place of 1, right? So now we are done. So this is how our priority queue will look like. So did you guys notice something here? uh, the the elements, the frequency of elements, or in other words, the elements whose frequency is less is placed at the top. Here you can see the frequency of number 3 is only 1, which is placed at the top, and the frequency of element 1 is 3, which is placed here, and the frequency of element 2 is 2, which is placed here. So the concept, or the takeaway from here is priority queue uses a concept called min heap, where parent is always less than or equal to child, which means your smaller values are always at the top compared to the uh, lower values, compared to the bottom values. But do we need this? Our question says we need the top k most frequent elements, which means we want to sort this in a descending order. If you look at our previous example, after we prepared the frequency map, we sorted it based on the descending order of the value, which means the value which has the most, which means the value which is higher should be placed at the top. Right? But then priority queue works on the concept of min heap, which always places the smaller elements at the top. So now what I'm going to do is I'm going to override the default behavior. So I'm going to change min heap to max heap now. Now if I'm changing min heap to max heap, the second property remains the same. We always insert elements from left to right, but then this condition becomes the opposite. Parent should be greater than or equal to child now. All right. Now let's try to construct our priority queue with this overridden property, right? So we'll have the first node, which is 3. We're going to insert 3 here, and then we're going to insert 2 as usual. Going to insert 2 as usual. Let's join this. Now let's revisit this property, right? So we inserted from left to right, which is good, and parent should be greater than or equal to child. 3 is greater than or equal to 2. So this is good now. We are not violating the condition. This is good. And then let's move to the next element, which is 1. So I'm going to draw 1 here. I'm going to draw 1 here. All right. So now let's revisit the properties. We inserted 1 after inserting left, which is good. And parent should be greater than or equal to child. No, 3 is greater than or equal to 1, which is good. So we satisfied all the conditions here. Now, when you went with priority queue's default behavior, min heap, you see the minimum values are placed at the top. Whereas when you overridden the behavior of priority queue to max heap, now the higher values are placed at the top, right? So now we need to find the top k most frequent elements. Now how am I going to get it? I'm going to get I need two elements which are occurring most frequently. So what I do a poll from this queue. When I do a poll, first this element 3 is popped out and this element 2 is popped out, right? So basically we're gonna get 3 and 2 from this priority queue. Now 3, now the element which is occurring 3 times is 1, and the element which is occurring 2 times is 2, which is 1 and 2, and that is our result, 1 and 2. Right? Make sense? So this is the intuition behind using priority queue. Now let's try to solve this. Okay. Uh, First, what we're going to do, we're going to prepare a frequency map as we discussed. So I'm going to have a map. Let me call this as frequency map. All right. So what I'm going to do is I'm going to iterate the nums. So let's have length here, nums dot nums dot length. What I'm going to do is I'm going to put int num of nums, right? I'm going to put frequency map dot put, right? So this is going to be num. I'm gonna go frequency map dot get or default. Default is 1. Okay, so maybe I'll put this in a separate line so that it's readable. Right, so I'm going to go to frequency map dot put. So num, the actual number is going to be the key, and I'm using frequency map dot get or default. So if that key is not present, then the default value is going to be 0, and then we append 1 to that, right? So if I'm going with 1, I put 1 here, the key 1 is not present initially, so that's going to return me 0. So 0 plus 1 is 1, so we found one occurrence of 1. So when you insert 1 again, uh, we have the value 1 which is present in the map already, so we're going to get the value as 1, and 1 plus 1 is going to be 2. You get the idea, right? So this is simple straightforward way to capture the frequency of every elements. Now once the frequency map is done, now we're going to use the priority queue as we discussed, right? So let's use priority queue, and this is going to be my integer. I'm going to go priority queue, or I'm just gonna use queue interface. That should be okay. Priority queue, right? But then, if you guys remembered, priority queue always uses min heap as the default data structure. But for this problem, we want max heap. So we have to override the default behavior from min heap to max heap. Now, how are we going to do that? So it's pretty straightforward. We have to sort this map based on the descending order of the value. So what I'm going to do is I'm going to pass a comparator here. So this priority queue has an overloaded constructor where you can pass a comparator as an instance here, right? So what I'm going to do is I'm going to pass es1, es2. Okay, so now since I'm passing entry set in the data structure, the data type of queue will not be integer anymore. It is going to be map dot entry of integer comma integer, right? So we're going to use maps entry set to sort our queue. So I'm going to pass es1 es2, and this is your default constructor, right? Es1 dot get value dot compare to es2 dot get value. Since we want this in a descending order, I'm going to put a negative sign here. Okay, now let's put the value of the elements inside the queue now. Okay, so what I'm gonna do is we already have this frequency map here. So what I'm gonna do is map entry integer comma integer m, and then we have the frequency map dot entry set. So this entry set is going to give you the key value pairs, right? And what I'm gonna do is I'm gonna do q dot add m, right? So this is going to give you an entry set, and then I'm adding everything inside my queue. So since we already have a comparator defined here, this priority queue will automatically do this reheap, or heap. We call this as a heapifying technique, right? Or heapifying process where these properties are checked and the swapping happens. So you don't need to worry about all those swapping. Java's priority queue will take care of that internally. You don't need to worry about that, right? So once you add all the elements into the queue, the number swapping, the checking of properties, all those things happens internally based on the condition that you have given here. You have said to Java that I need to sort my queue based on the descending order of the value. Right? So now once this is done, It's very straightforward. We're going to have a result array because the return type of this method is array. I'm going to have new int, then I'm going to pass k because we're just interested in the top two elements. Right. So now what I'm going to do is I'm going to do for I equals to 0, I less than k plus plus. I'm going to put result of I equals q dot poll. Okay, now this q dot poll is going to give you an entry set, but then we are interested only on the key or the actual numbers. So I'm going to put get key. All right, simple. Then let's return this result. Let's try to run this. Right, the code is good. So let's try to submit. Yep, our solution got accepted. All right, so this is it, guys. I just wanted to share this knowledge with you all. This priority queue was a new topic, or a new thing that I learned recently. So I thought I'll share my understanding with everyone else. So if you guys learned something from this, please consider liking and subscribing. Thank you. See you again.